So, this is the car that I've been working on for the last few months. It's for a game that I'm making. I currently got the car to drive, added a bunch of cool animations, like the one you just saw in the intro. Yeah, that was a boost animation for this car. So I decided to be sharing these devlogs. So before any of this existed in 3D, it started with a lot of references. Rear and rover defenders, sci-fi vehicle components and concepts, anything with the kind of style that I was going for my game. I just started putting pieces together from all of them, mostly being the Land Rover defenders, because this is what I wanted the player to be using as the car in the game. So at this point I had already modeled the components of the vehicle and the asset itself. I had already paired them together, going for the style that I was looking for. This isn't the final look, but it's worth moving to the next step. So I knew early on that I was not going for the realistic look. I liked that stylized look, that rough kind of sketchy look. So I started texturing in Blender, but I had to use the paint system add-on in Blender, because with this add-on you can have a layer based workflow, which is so awesome. So with this add-on I had to create layers of different parts of the vehicle, and these layers are basically, you can't break these layers, so one change in one layer will not affect another layer, so I can later come in and make changes to any layer that I want. And on top of that, you can have different channels, like you can have channels for, you can have data in the color channel, where you put all the beautiful details. You can have normal details in the normal channel. You can have details in the metallic, the roughness. So it's a really good add-on. Okay, so this is the part that most of you are already familiar with, and dare I say most of you anticipated for this part, the animations. So I'll be giving a summary of how I created this rig and the animation. It will be a very short summary because this is a devlog. I wouldn't want to get too technical about this. Okay, so I created this rig with every bone controlling a certain part of the component in the booster. So with these bones controlling specific components in the booster, I had to add bone constraints to these bones, and one constraint would control a certain aspect of this bone. Like for instance, having this transformation constraint means that the scale of one bone will affect the rotation of this other bone. And because I have multiple transformation constraints, I can tell one bone to control multiple other bones. So I can set the scale of one bone and have it tell a bunch of other bones that with the scale of this bone, I can have this other bone rotate, I can have this other bone scale, I can have this other bone move, which that would be the location. I know this might sound like hogwash or yeah, a bit technical, but that's essentially it. So having one bone control another bone using the transformation constraint. Mostly of this rig is the transformation bone constraint. Yes, so you'll have one bone and one channel that will control multiple other bones in their channels based on how you set them. So yeah, that is like a short summary without me being too technical. But you guys tell me what you think. Maybe we could expand on this based on input. So this is the antenna animation. So this one was a bit simpler compared to the booster animation that we just saw, because this one has fewer components and its animation is a lot simpler. Basically it has protruding components where it comes out of the roof, and it can also retract, as you can see, and it also uses the same philosophy of the transformation constraints. So getting into Unity is where the stylized look really comes together. As you can see, the car has that tone style look, which is what I was going for. The tone style look, the stylized look, and not the realistic look that we are all used to. So yeah, the look has two components. The first one is the outline look. This one governs the broader look, the harsh broader look of the components on the vehicle, and the second part handles the intersections. And this is how the vehicle looks without the outlines and the intersection lines. So these two custom shaders really do bring out that look. They really bring out that signature stylized look. And they weren't very complicated shaders really. And how the shader works is essentially we are calculating the depth, as in the depth difference between the center pixel and the surrounding pixel. This does work in calculating also the ambient occlusion, and you can also tweak it to calculate the intersection between two faces. And with this data we can then create this shader, the intersection lines shader. Now, how does the vehicle actually drive? How does it drive? So I decided to go with the raycast approach, which is essentially rays being shot from certain positions. If you look closely on the wheels, you can see very thin green lines going down, and those are our rays. So with this approach, we are basically shooting rays from these designated points going down to the ground, and these rays are checking if we are hitting the ground, and if we are hitting the ground, then the vehicle becomes, it looks like a vehicle, so it becomes elevated and it applies a force to make it seem as if the vehicle is resting on these wheels. The reason for going with rays instead of wheel colliders is that with rays you get much more control compared to wheel colliders. You can customize to get the feel that you want, and it's so much better at fine-tuning it. As you can see here, the vehicle goes up and down the bumps, gives you that really good control. So this is a code preview of how the suspension is applied. So we basically shoot rays, we check if we hit the ground, and if we do hit the ground, then we apply suspension force. After we have successfully added suspension forces, steering becomes easier because we can simply add forces in the left and the right direction. So it becomes easier to steer the vehicle after we've already figured out the suspension forces. So now let's apply our animations. Applying the animations, I had to take the state machines approach, which is basically I had to create different states in which the animation will be playing, where the first state the animation is basically not playing, and then in the second state the animation starts to play, and then in the third state the animation stops playing, and finally the animation reverses playing. So this would be your reverse of the animation. And because our animation relies on these two aspects, which is the animation playing forward, and in this case it's the booster coming out of the vehicle, and in another essential case is the animation playing in reverse, which is the booster now coming back inside the vehicle. And it's really complicated doing this with blend trees. Yes, with the traditional animation blend trees, because with blend trees you'd have to create two separate animation clips to do this. Yes, but I didn't want to overcomplicate having multiple animation clips of basically the same thing being in reverse. So this is why I took the approach of using state machines, where we use simple animation clips and play them in forward and reverse direction. As you can see right here, both the animations of the antenna and the boosters are working, and you can see they can even be laid on top of one another. Yeah, because I also had to use animation layers for that. Turns out you can't lay two animations on top of one another without having an avatar mask, so you'll have to create an avatar mask for that. And essentially that's the first devlog. Thank you for watching all the way to the end. I'll probably have another devlog in some time, not too soon though, because I have a couple of stuff to do, but hopefully see you guys soon.